everyone, welcome to Ferris Wheel's Day 2. In today's video, I'm going to show you how to write the trig equation of a Ferris wheel given the information here. So let's refresh our memory of this problem. So again, we're talking about a Las Vegas high roller, currently the tallest Ferris wheel in the world. And the first important piece of information is that it takes the riders 30 minutes to go around one full time. So that should be a hint that we're talking about period, because period represents one full rotation. So one full rotation is 30 minutes, therefore that's my period. The next piece of information that we want to talk about is that the Ferris wheel reaches 550 feet above ground at its highest point. So what that means is the distance from the ground to the top is approximately or exactly 550 feet. So that will tell me that my maximum height is 550. Then the next piece of information is the diameter of the wheel is 520 feet. So this distance from the bottom of the Ferris wheel to the top of the Ferris wheel, this is 520 feet. So the conclusion that you can get from that is actually the minimum height. So where do I start entering the Ferris wheel? I want you to think of the situation like this. You walk up some stairs and then this is where you enter your Ferris wheel. So if you take this 550 and subtract 520, you'll actually get 30, and that's the distance from the ground to the entrance point. So that's 30. So that'll actually tell you your minimum height. So your minimum height is in fact 30. So this is honestly all you need to make an equation of a trig function. So the first thing that we have to do is decide what type of graph this is. Is it a sine graph or is it a cosine graph? Because we have two options here. We either have y equals, well actually I'm going to change the color. So we have y equals a sine bx plus or minus d, or we have y equals a cos bx plus or minus d. So let's draw a picture and then we can decide which equation we should write. So like yesterday, we have our time on the bottom and then we have our height on the y-axis. So on the height, we know that the maximum height of the Ferris wheel is 550 and we know the minimum height is 30. So if we're drawing a sketch, it's pretty obvious that the person will start on the Ferris wheel at 30 feet rather than at 550 feet. That's very large, high. No one is going to get onto a Ferris wheel and start up here. You walk up the stairs and you start here. So our sketch is going to look something like this. We start at 30, we go up to the highest, and then we come back down to the lowest. So if you look at this picture, it's pretty clear that this is not a sine curve, but it's a cosine curve. So we can go ahead and cross off this one and know that we're going to write an equation in this form. And the things that we need to remember is that we're going to leave a space for our amplitude. We're going to leave a space for our cycles and a space for our vertical shift. I put that plus or minus there so we can make a differentiation later. So this is my amplitude, this is my cycles, and this is my vertical shift or my midline. And like we did in previous videos, we're going to start with the midline. This is step 1, find the amplitude is step 2, and then find the number of cycles for step 3. So again, midline is the maximum value plus the minimum value divided by 2. So here is our midline, and that's what we're going to try to find the equation of. So the maximum value is 550 plus the minimum value, which is 30, and if we divide that by 2, we'll get our final answer, which, if my memory serves me correctly, is 290. So you can go ahead and make it a positive 290 because the answer is positive, and that's our midline. Now, if we know that our midline is 290, we could technically find our amplitude, and the amplitude is the distance from the max to the midline. So this is my amplitude. So really all you need to do is subtract 550 and 290 to see how much distance has been covered there. So I'm going to write for amplitude, I'm going to write maximum minus the midline, and the maximum value is 550 minus 290. And that gives you 260. And then the last thing that you need to find is the value of B, which will be your cycles. So if you remember from the previous videos, we need to use the period. So I'm going to put that on the top over here. So period equals 2 pi over B, where B is the number of cycles. We know the period is 30 minutes, so I can go ahead and put 30 in for the period and solve for B. And remember, to solve for B, we cross multiply. So you should get 2 pi equals 30B. Divide both sides by 30. And you can actually reduce 2 and 30 is 1 over 15. And we keep the pi. So 1 pi over 15 is your B. That is your number of cycles. So when you put it into the equation, you don't need to put the 1. So you can just put pi over 15. And then just one last thing is that since this is a negative cosine graph, our final answer should have a negative 260 in front. And that's it. That is your equation of your cosine curve. Okay, so from that last example, I mean, you really can make a conclusion, and to answer the question from yesterday, is that all Ferris wheels will be cosine graphs. And they'll actually be negative cosine graphs. So y equals a cos bx plus or minus d is really what we are trying to find. We're trying to find that equation. So in this particular problem, we have that the diameter of the Ferris wheel is 80 feet. So I'm going to go ahead and label the picture with 80 for the diameter. So from the top to the bottom is 80. And then it tells us that it takes 4 minutes to complete one full rotation. So again, you should be thinking one full rotation is period. So we know that the period is 4 minutes. And they also tell you that Johnny begins his ride at 10 feet above the ground. So from here to the ground is 10 feet. So we know our minimum value. My minimum value is 10, that's where I start. And we could find the maximum value, how high off the ground we are, right here, if we measure from here to here. This is the maximum height. So 80 plus 10 will give me 90. That's my maximum height. So again, that should be enough information to give me my cosine graph. Now the sketch will be very helpful yet again. So we have our time on the x-axis and we have our height on the y-axis. And we know the maximum height is 90, the minimum height is 10. And we know when we start a cosine graph, you know, we're always going to do a Ferris wheel problem from the minimum. You never enter the Ferris wheel from the top. So we start at 10, we go up to 90, and then back down. That takes a full 4 minutes, which is my period, and we want to find the midline, right? That's always going to be our first step. So we have y equals something cos something x plus or minus d. So again, this is my amplitude, this is my cycles, and this is my vertical shift or my midline. And we always start here first. We find the midline, then the amplitude, then the number of cycles. So my midline is the max plus min divided by 2. In this case, the max is 90, the min is 10. Add them up and divide by 2, you should get positive 50. So you can go ahead and change that to a plus 50. So if this height here is 50, then how much more would I need to get to 90 to find my amplitude, right? From here to here is my amplitude. So to find the amplitude, you can just do the maximum minus the midline. And the maximum is 90, the midline is 50. If you subtract them, you get 40. And remember that this is going to be a negative cosine graph, so you need the negative 40 in front. And then the last thing that we need is the number of cycles. We find that by using the period. So I'm going to write this over here, that period is equal to 2 pi over b. And the period is 4 minutes, and we're just going to cross multiply to solve. So we're going to cross multiply. We get, I'm going to write it up here, 2 pi equals 4b. Divide by 4, and you get that b is equal to 2 out of 4, which is 1/2, or pi over 2. So that goes in here for your number of cycles. So your final answer is y equals negative 40 cos pi over 2x plus 50. And that is your final answer. All right, that's it for today. If you have any questions, let us know.